So taking a look at DHCP snooping, if you're not familiar with DHCP snooping, it's really not again, it's a security feature that's not really in any way new to the Nexus, 7K, 5K, 2K, but it's certainly something that's available and certainly something that we will use probably in our data centers. If you're not using it, especially with the new bring your own device type initiatives, this is something that is being used more and more. As we're going to take a look at the next three sections, DHCP snooping, IP source guard, and dynamic ARP inspection. Those other two, dynamic ARP inspection and IP source guard, both look at the DHCP snooping database in order to make MAC address to port, MAC address to IP address correlations, and so they're going to be very important. We are also using the DHCP snooping database more and more in the Bring Your Own Device initiative, where we can really gather information about the device as it comes onto the network. As a non-server, a client comes onto the network, it's going to almost always ask via a DHCP request for an IP address and other information like DNS server, possibly domain name, certainly default router, and possibly some other information, TFTP, other ancillary information, etc., in order to participate, of course, on a modern IP v4 or v6 network. And so using the information that we have from that DHCP capture, we can begin to profile individual devices. So we're not going to go into all of that today. This isn't certainly a security centric class, and we could go really quite far in depth just on Bring Your Own Device, and in fact that's something that I probably will be recording a number of new videos soon, dealing with the ICE server, dealing with certainly the Cisco TrustSec architecture, which includes Bring Your Own Device and all those other things, but those will be up and coming. So just taking a look at DHCP snooping at its basics, DHCP snooping is analogous to a firewall between really the untrusted hosts or clients and the trusted DHCP server. So the idea is we don't want to allow any untrusted DHCP servers, any rogue DHCP servers, onto our network. We don't want anyone answering for our authoritative, actual DHCP servers and kind of answering on their behalf, giving IP addresses out and possibly giving fictitious default gateway or other fictitious information or attributes to our end hosts, sort of playing man in the middle, but in the sense of intercepting the DHCP requests and giving erroneous or different information. So we want to make sure that only responses from a trusted DHCP server, really from a port that I designate as a trusted source, those are the ones that are handing out the replies. So we're listening to all the requests, and we're also listening to the replies, the switch is listening to the replies, and making sure that only the validated sources hand out the DHCP replies. So that's the idea behind DHCP snooping. So DHCP snooping validates DHCP messages received from untrusted sources, and it also filters out invalid requests. It maintains the DHCP snooping binding database, which contains the information about the untrusted hosts or clients that are requesting their leased addresses, and it uses that information to validate subsequent requests from those untrusted hosts or clients. Now, DHCP requests could come in from a VPC member port. So looking at DHCP snooping in a VPC environment. So keep in mind with a VPC environment, we've got two peer switches, and we might have a request coming in on, let's say, peer switch A, a primary, and the response might come back on peer switch B, the secondary. So we need to make sure that the information is correlated. And this is actually something that if we didn't have it correlated, we would have a mismatch or certainly incomplete DHCP snooping binding database or table. And this is going to break IP source guard, and it's also going to break dynamic ARP inspection as well. So what we use is CFS over Ethernet. So this is distributed over Ethernet, not over IPv4. And we know we can do show CFS application to see which CFS, or I should say which applications via the Cisco Fabric services are distributed over Ethernet versus being distributed over IPv4. And we basically use CFS over E to synchronize and resolve this situation from occurring. This also forces only one switch to forward the DHCP request response, and then it synchronizes the other. So after we turn on feature DHCP, and globally we turn on IP DHCP snooping, then we begin to apply the DHCP snooping commands to each VLAN that we wish to actually monitor for DHCP snooping. There's really nothing more that we need to do behind the scenes in order to make sure that the VPC peer has that information. Okay, CFSOE is going to make sure that only one of the switches forwards that response, the request response, and then it's going to synchronize the VPC secondary to have the same snooping binding database. So if we do a show command, show IP DHCP snooping binding on either VPC peer member, we will see the same database. Optionally, we have the ability to run IP DHCP snooping verify MAC address. And what this is going to do is basically say that if we receive a packet on an untrusted interface and the source MAC address and the DHCP client hardware address don't match, then the address verification causes the device to drop the packet. So this is very, very similar to IP source guard but just at a MAC address port level implementation. So on whatever interface or possibly port channel, we have the actual trusted host. So where the DHCP server is coming from, we would want to run IP DHCP snooping trust. Okay, so this is going to trust anything that comes in on this port. This is typically where we actually have the DHCP server. Every other port is untrusted. Almost every other port will be either a switch port out to another host that's running DHCP snooping as well. And we will have all the clients as well. They will all be on untrusted ports. So they're untrusted, that's fine. The request comes in. It's just that responses from any port other than a trusted port will be dropped. Any response that comes from a trusted port that we've just configured, this will actually be allowed, and the response for the MAC address was in, of course, the request. It will be in the response message as well, and that DHCP response, along with the port that request came from, those will be set in that DHCP snooping binding database. Okay, something else to take into consideration is that if DHCP server and client are in different VRFs, we may and will need to turn on IP DHCP snooping information option, so option 82, and also tell that information option about the VPN or VRF. So VPN routing and forwarding, or virtual routing and forwarding, however you want to necessarily say that V in the acronym is defined. The VPN command, or argument, I should really say, at the end of the IP DHCP relay information option is something that we need to have for a smart DHCP relay. And we can also, we also need to specify IP DHCP relay sub-option type Cisco to make sure that that is written to the request across VRFs. Okay, so that's using option 82 and the Cisco-specific sub-option in order to allow it to go across or transit across VRFs. So IP ARP inspection is something that basically uses the DHCP snooping binding database in order to build a MAC to IP address check. So this validation helps to prevent man-in-the-middle attacks, and we do have to have IP snooping turned on for the particular VLAN that we want to run ARP inspection. And then what happens is we have this IP-ARP inspection validate command for the particular VLAN. And then, of course, we can also trust particular interfaces. We would trust, for instance, the DHCP server, certainly, or any interface that is not going to have a mapping, a dynamic mapping. So basically any interface that's not going to get DHCP information. So we would probably trust most servers that aren't getting DHCP, that they aren't asking for DHCP. We don't necessarily have to trust them from a DHCP snooping because they're not sending DHCP responses. But servers that have static IP addresses, we are typically going to put on for IP-ARP inspection trust, or optionally, it's a little more cumbersome, it's a little bit more overhead, but optionally we could create static ARP entries. And that would effectively trust them as well. So now the only thing is that this is only going to validate the Ethernet header, source MAC, and against the database by default. So this is only really for ARP inspection, and we can enable additional validation checks. So we can say that the IP-ARP inspection should validate the source and MAC address, okay, for ARP requests. So by default, the ARP inspection only validates the actual ARP message, which is encapsulated in the Ethernet header. The source-MAC actually validates the outer Ethernet header, source and destination MAC, well, I'm sorry, source MAC in the source-MAC case. The next one is destination MAC, and we can check that as well. We can even go so far as to say the IP. So this will check the ARP body for invalid and unexpected IP addresses, such as all zeros or all bits turned on, all 255, and even multicast addresses. And we do have one other ability, which is to be able to filter out ARP requests. So we can permit certain ARP requests from, let's say, here I've got an example of the host of 10.0.0.1, and the MAC address is all zeros, and that last bit is a 1. And then we can filter those particular access lists on VLAN. So we can say IP-ARP inspection filter, unknown switch is just my tag, VLAN 10, and so it's permitting an ARP that has that host IP address to that MAC address mapping. But everything else is pretty much denied in terms of ARP. Looking at IP source guard, this is similar to dynamic ARP inspection, only it's on every packet, not only ARP packets. So I can have static bindings, IP source binding. Here I've got again, the same IP address to same MAC address mapping on a particular VLAN and on a particular interface. I can, on a given interface, and again, I have to be running DHCP snooping. I have to use that DHCP snooping binding database for all of my MAC address to IP address and port mappings. So I say IP verify source, DHCP snooping VLAN. And of course, if we look at the entire configuration, I might have on a switch port, it would be something like, maybe IP DHCP snooping trust from a server, specifically a DHCP server, on just about any of my statically mapped IP address or statically assigned IP address servers or any other devices, the IP ARP inspection trust, and possibly the source guard as well, IP verify source DHCP snooping VLAN. So next, looking at different forms of hardware protection in NXOS. Taking a look at storm control. So storm control, again, not a new feature in any way, something we're probably all fairly familiar with by now. One thing to note, and commonly misunderstood, is that the values for broadcast, unicast, and multicast storm control, they're really not individually set. The last entered value really changes all of the values. So really one suppression level is shared by all three modes. So for instance, if I have interface Ethernet 1.1 or any given interface that I choose to turn storm control on, and I say storm control broadcast level 35%, so 35% of the traffic coming in being broadcast, it should begin to drop that. And then I say storm control multicast level 30. This actually changes the broadcast and the multicast level to 30. And either broadcast traffic that's coming in at 30% of the line rate, or multicast traffic, or really an aggregation, either one of those that's taking up 30% is going to shut down that, well, not really shut down that port, but begin dropping that type of traffic, broadcast or multicast respectively. And again, if I say storm control unicast level 25% and any one single flow of unicast traffic is taking up more than 25% of the interface, that is going to be the new value. So it's really a single value that is used for all of that storm control. And the documentation, I copied just a couple pieces out of the Cisco.com documentation website. And basically, it states the same thing, that if you enable broadcast storm control and broadcast traffic exceeds the level within the 1 second interval, that the traffic storm control drops all that broadcast traffic until the end of that 1 second interval. If you enable broadcast and multicast, and the combined broadcast and multicast or aggregate exceeds that level, it will drop both forms of traffic until the end of the interval. If you enable broadcast and multicast storm control collectively and broadcast exceeds that, traffic storm will drop all broadcast and multicast. And this is one of the things that people, I don't think, necessarily always read carefully enough or understand. So if both broadcast and multicast aggregate exceed that 1 second interval, whatever it is that I've set, and I don't just have to set a whole number, I can set a fractional number as well. In fact, the fractional number can be very useful when just testing this out. If you want, instead of setting something like storm control broadcast level, even 1 for 1%, set something like storm control broadcast 0.1. So 0.1%, or even 0.01, 1/100%. That's the level that you can go down to, is a 1/100%. And that way you can test with like broadcast pings, or you can test multicast traffic with pings, as Brian was doing yesterday in some of his multicast over OTV examples. And we can actually see that if a combined broadcast and multicast traffic exceed that, it's going to, or I'm sorry, if just one of those flows exceed that, it's going to begin dropping both of those types of traffic. So just multicast exceeds, let's say we have it set at 1%, and just multicast exceeds 1%, but we have broadcast and multicast configured, it will begin dropping both broadcast and multicast until the 1 second interval is up. It takes a new sample, and it is no longer at 1%, it's below that threshold. And then finally, it says if you enable broadcast and multicast traffic and multicast exceeds that level, it will also drop broadcast and multicast. So either one of those offending types will drop it. This is one of the reasons people typically turn on storm control for broadcast and multicast. They do not always turn it on for unicast, because if any one of these exceeds it, it's going to begin dropping traffic for all that are configured. So use storm control for broadcast and multicast. Use it for unicast very carefully. We also, for hardware, the actual supervisor and just box protection in general, we actually have a hardware rate limiter. So we configure the rate limiter for packets forwarded to the supervisor, such as control plane policing. And we're going to actually take a look at control plane policing a lot more in the QoS section. We'll take a look at actually the default control plane policer or set of access control entries and ACLs that are configured. Actually, I shouldn't say ACLs, but really the MQC structure that's set up in the Nexus 7000 by default, and we can see how to apply that to the system. We'll take a look at that in the QoS section. But there is an extremely granular, well thought out, covers pretty much almost every base that you could imagine for control plane traffic in the Nexus 7K.